Hi, I'm Jeff Richards, AWS Solutions Architect, and I'm delighted to say I have with me today my good friend Phil Ma, CTO Government Systems at Viasat. Phil, welcome to Remars 2022.
Thank you. Thank you, Jeff, for the kind introductions. I think today I'm actually very grateful that AWS invited me to have a chance to actually talk to all of you guys about space, as well as how space company use AWS. And then we are actually jointly able to actually deliver this capability to places that people never imagined is actually possible. So a little bit about our company first. We found our company approximately 30-some years ago. We are a global company. We have office obviously in North America, South America. We actually have pretty much a good presence basically in the Middle East, in Europe, in Africa, and also Australia. So we are pretty much in all of the continents. And right now we have about, when we actually start counting, basically we have 6 satellites in orbit. The current generations, the highest capability one is 250 gigabit per second satellite. It's what we call Viasat 2. At the same time, we're actually building 3 more really great capability satellite. It's going to be in space starting the end of this year and then into next year's. Those are actually what we call Viasat 3. Each satellite is going to be able to do more than 1 terabit per second. So from a global point of view, we're going to actually have like 3 terabit per second in a global sense. And that's actually what we'll be able to do to deliver communications to a lot of people around the world. We have about 6,000 people, employee. We do about like $2.3 billion last fiscal year. So as a satellite ISP, we're actually one of the biggest one in the planet. So one question is like, who's our customer, right? So the first things to think about is that we actually can look into like 4 categories. We have a lot of what we call consumer residential customer. They are in the US, they're in Canada, Mexico, as well as in Europe, and then also in Brazil. Those are our main residential customer. People in Australia also use a lot of our equipment basically to get satellite service as well. Outside of that, basically, we are also doing a lot of what we call airborne connectivities to the airlines. So if you actually fly in the US, there's a good chance that you can actually, sometime you'll be using our service basically. So we are in American, United, Delta, JetBlue, and then we actually are in many of the international airlines also, providing internet connectivity when you are in the airplane. That allow you to do all the work that you wanted to do, so you don't feel like that you're disconnected when you're flying. On top of that, we recently actually have signed with Southwest also, so I believe that sometime next year, basically, you're likely going to actually get part of the fleet to using our service as well. In the government side, basically, which is actually where I actually spend most of my time working on, we also do a lot of what we call airborne connectivities for the governments. One of the fleet that we're supporting is actually called VIPSAM. The VIPSAM fleet is basically a fleet of airplane that service all our national leader. So we're actually providing all of the dignitary and the national leader the airborne connectivity at the same time. Ships. So as you can know that ships is actually where there's actually very difficult to get service as well. So we're in actually 2,000 ships, ranging from passenger ships to commercial sea liner basically. So you can see that we actually cover a wide variety of locations as well as people in different vehicles, ships, as well as on airplane. One thing that we're actually pretty proud of also is that we actually do a lot of what we call community Wi-Fi. Those are the hard-to-reach area when people can't afford to have their own internet service, but they can actually go get our service into like a concentrated area, in a rural area, in third world country, and actually have the ability to go connect to the world. As you can imagine, basically, given our current capability and the reach of as a global network, we have a lot of need basically on both data analytics and how to manage the systems. And we have been, I believe that we're actually one of the first space and internet service company work with AWS. I was actually just talking to Jeff right before that and start counting. It's like about 10 to 11 years ago that we will start working with AWS. You can imagine that this is actually when cloud is actually not even a word that most people understand, and most people actually doesn't understand how to do data analytics. So we were actually in the ground floor, basically working with AWS as we build out our global satellite network. So our Surface is actually ranging from some of the most fundamental infrastructure as a Surface like EC2 or S3. We also actually use some of the advanced Surface, basically, such as SageMaker, to actually run some of our ML operations. On top of that, we are actually leverage a lot of the AWS network as part of our network also. So as a satellite ISP, we have a pretty sizable terrestrial network global to connect everybody so that when someone in Australia can actually easily talking to people in Europe and the US. But we also actually leverage the network that AWS has to build out, basically. So I think we actually find a lot of synergies to actually provide capabilities across the board to a lot of people. We are also have several direct connections with AWS. For people who are actually familiar with that, is that this is actually where that we can actually connect our own data center directly with AWS data center in the hyperscale cloud. That actually brings tremendous, basically, capability from the point of view of security. So anybody can actually go talk and actually can do their internet without actually their system, their informations going through the internet. You can actually connect someone anywhere around the world, and then you can actually put something in the cloud, and then you can extract something in the cloud without actually going through the open internet. This is actually a very important security features, so that your information cannot easily be eavesdropped, and then will not allow people to do what we call traffic flow security. So this is actually particularly important for any kind of like government operations, as well as enterprise that is actually holding very important operations, protect their intellectual properties when they are, for example, industrial control systems that actually are doing very critical infrastructure work, basically, in their respective area. So this is actually one of the key things that we have been working with AWS for quite some time. So the question will be next, so what kind of application do you use and we work on with AWS? Well, the first thing is that we actually started with what we call big data analytics. As an ISP that I mentioned, that we actually have millions of residential customers around the world with thousands of planes, thousands of ships. And in order to be able to actually manage the system well, we collect a lot of data. So how do we actually use those data, right? Well, first of all, we actually have to use those data to make sure that we can actually manage our space assets correctly. Because as a satellite ISP, our most precious products we're selling, basically, is those bandwidth we converted to bit, basically, so that we can serve the world, around the world, and actually provide connectivity. So one thing important is that we start with data. Another thing is that we have to understand the demand of the user very well. Because, for example, the demands is, people will think about, oh, the demand for communication system is actually pretty static. That's absolutely not true. You can be impacted by weather. You can actually impacted by world event. You can actually have been impacted by a lot of different scenarios. So we actually use that to actually try to actually make sure that we have a really good demand forecast on who actually want to use the capability. And then we actually have to match the demand with the resource that we have, which is our spectrums, our ability to be able to deliver those services as we need it, basically, in real time and sometimes almost real times. We actually have a pretty sizable satellite fleet also. We actually need a lot of data to make sure that we can actually monitor the satellite, we can actually manage them. And then finally, we actually match it all together. We actually establish like what we call usage model. So that we can actually use all of the data that we have collected, analyze basically in the cloud, and then we can actually go do like advanced plannings on how we're going to try to change, reconfigure the system so that we can actually give better service to our customer, but also aiding us to actually build and design the new next generation satellite. So in here, I'm going to actually give an example basically on the kind of data analytics that we do. So one of the key things about the internet today is that there's a lot of malware. There's a lot of malicious traffics around there. And as a satellite ISP, those malicious traffics is actually costing us money. The reason is because for every bit that is actually being occupied by malicious traffic, there is actually one less bit that we can sell to our customer. And then the customer is not happy because if they are actually, they will feel like that, hey, wait a minute, how come my internet is slow? Well, it's actually because their system is actually being infected, and therefore they actually transmit a lot of what we call like malicious traffic in our systems. So we have been actually investing quite a bit of times and monies and resources to try to understand these malicious traffics and how we can actually get rid of it. So as we actually mentioned before, we actually collect a lot of data. Right now, in a daily basis, we actually have about like 500 terabyte of data delivered by our transport network right now with our current 6 satellite fleet. And we actually have to collect and analyze about 30 terabyte per day. That's the amount of data that we actually have to collect and analyze. You can imagine that basically in about 2 years, that particular number is going to be tenfold. We're going to have like 10 times as much data basically through our systems. And in the same time, it will be the same thing for the data that we need to analyze. One of the things that we are actually very active in our communities actually understand what we call threat intel. So this particular example, this is actually not the only example. This is the one example that we are working with DHS. DHS actually have a collaboration program called Information Sharing and Collaboration Program. This is actually how DHS actually work with private industry to try to develop better threat intel, basically, cyber threat intel, so that we can actually protect the networks better. So this example is something that we actually, in October and November in 2021, they provided us 125 IP addresses. This is actually what we call a IOC indicator of compromise to us. And this IP address indicated that those IP addresses actually have been part of the TrickBot systems. What is TrickBot? TrickBot was originally developed by bad actor, allow them to be able to actually use it on the banking industry to steal credentials. But as this particular family of malware continues to evolve, it's already what we call a full malicious family of ecosystem that they developed to try to do more than just affecting the banking. So the way that we were actually using this data is because Viasat actually have a lot of internet traffic basically, and we actually need to protect our customer and our network. So we actually took that 125 what we call IP address of IOC, we put that in the systems, and we actually apply analytics on our own database basically for 24 days. And we discovered that 47 of them actually show up, which is actually part of the user, not our management system, as the user base basically. And that is actually very important because this is actually allow us to actually understand, there's 127 basically, we at least see 47 of them in our systems. But it's actually more important than that. The reason is because we can actually go look at those 47 address and see how do they communicate with, who do they communicate with, and the patterns of the communications. So as you see that we actually, afterward, we know that out of those 47, 77 of them actually have bidirectional connectivity to other IP addresses. 17 actually we can actually observe inbound, and then 6% we observe outbound. So when you actually look at this particular chart on the left bottom side, we have been able to develop a lot of different patterns of communications. So what you can see that on the top right corner, you can see that it's like one IP address that was actually provided to us that talked to many basically. That is it is a good indication that that particular IP address is actually being used as a mass, what we call C2 system, command and control of malware. This is a system that try to spread malware or maybe try to use that use that particular IOC IP address to control other computer. And then you also see different patterns, basically. Maybe they only connect to one or two. Maybe the other one that they have is actually where they develop the malware. And then they actually try to deliver the payload. So by doing all this, we have been able to much better protect our systems. And what we're actually able to see is what we call amplifications. Amplification meaning that from those 47 basically IP address that we see in our systems, we can actually able to actually detect all of those informations being traversed into different IP addresses, and we can actually grow up to maybe 100 of them and further understand that those could be actually bad IP address that we either need to block, we need to monitor, or we actually need to quarantine. So this is actually why it's actually important, basically, as we actually go up the ladder on understanding what we call TTP, tactics, techniques, and procedures, instead of just the IOC. So as we actually go up what we call the IOCs, you may be in a malware, basically, you might actually have a hash values. You might actually have an IP address. You might actually have a domain names. Okay, those are important information that the attacker need to use to attack someone. But those are easily changeable. You can recompile your hash. You have a different hash values. You can actually change from like one IP to another IP. You can change the domain name relatively easy. What is actually more difficult to try to change is the fact that the tool they use, basically, the specific state machine of the attack is going to accomplish, basically. And those become what we call the TTP, basically. So we have been able to use all this data analytics capability that we actually run on AWS to actually elevate from what we call from an IOC to IOA, indicator attack, so that we can actually better protect our network. So this is actually just one of the area that we use with our data analytics to improve our performance, because the one bit that we can actually block the malicious traffic is actually like one more resource that we can actually provide to our customer. The next thing, I'm going to actually shift the topic a little bit, basically. Previously, we're talking about how Viasat and AWS, we have been able to use the Surface, basically, to actually run our network. But we actually have also a very important relationship with the fact that Viasat, being a space company, being a SATCOM company, we can actually help anybody in the world to actually harness the power of the cloud, no matter where they're located, whether or not you're in land, whether or not you're in sea, whether or not you're in air or in space. So this particular diagram actually demonstrates one of the very important use cases that we're actually working with AWS. Imagine you are a soldier, a war fighter, in the middle of nowhere, right? And it will be very important, for example, if you can actually get all the information's processing capability like anybody else right now, like me and you, basically in the middle of city. The fact of the matter is that when you actually use a cell phone, a lot of the power that you can actually able to use is because it's actually connecting to some kind of cloud, basically, and those are the ones who's actually doing the processing for you. When you're a warfighter in the middle of nowhere, that's actually much more difficult. So I think in this diagram, what we have been able to show is that, hey, with the communications, with the SATCOM capability that we actually have, is actually what we call software-defined wide area network. We can actually connect like vehicles, a Humvee, and other, you can maybe in the command post, basically, you can actually connect that into AWS through our SATCOM connectivity in this what we call SD-WAN arrangements. As you can see that we have a satellite dish in here. We have a whole bunch of different satellites we can interface with. The airplane, for example, as we said, we can actually do that as well. And then you can actually connect to AWS that way. On the left-hand side, basically, is something that a lot of people don't know Viasat is doing, basically, right? People were thinking about Viasat, well, you do satellite communications. That's true. We do a lot of satellite communication. But we also do a lot of what we call tactical communications. We have tactical radios that we have developed. So those are the radio that is actually handheld, allow people to be able to communicate what we call line of sight, basically. Okay, we call satellite communication beyond line of sight because you can be like very far away basically, and then you can actually use the satellite to actually communicate. So in this particular case, what we can do though is that not just actually provide satellite connectivity to like vehicles or command posts. In the case of a dismounted soldier, basically, a soldier on their own, they can carry a satellite dish, but they can actually have tactical radios with them. And they can then actually go through what we call in the middle is actually what we call a gateway, a satellite gateway, and a tactical radio gateway. And then the tactical radio can actually talk to the gateway can actually go talk to the SATCOM terminal. The SATCOM terminal then can actually go through over the air and connecting to AWS. So you can see that we're actually able to provide this connectivity, truly putting the power of the cloud into every individual soldiers in their hand. So this is a very powerful proposition basically, as everybody know that right now it's important that right now warfare is actually all about information basically and your processing capability and what you can get to. So it is a very important part of what we do. The next chart, I'm going to actually invite Jeff come up to the podium. This is actually what we do together in the Sea, Air, and Space Expos, I think about this time last year.
Yeah, that's right. Thanks, Phil.
Okay, right.
Okay, a lot of words on this slide. Hope this doesn't distract you too much. So AWS worked with Viasat over the last 2 years at the CS Space Expo in National Harbor in Maryland. And the intention was to showcase Viasat's ability to, in conjunction with AWS, to deliver highly available, resilient comms into challenging environments and also compute facilities. So these edge locations, as Phil alluded to on his previous slide, these could be simply remote areas of operation. So this could be mining exploration, this could be gas exploration. It could be disaster areas. They could be areas of earthquake or forest fires, or areas of military conflict. So the idea was at the two expos that we wanted to showcase how well Viasat and AWS could work together to bring each company's services together to a common end. So there's some photos on this slide, as you can see. So Viasat brought along their satellite backhaul infrastructure. On the back of that truck, we actually set up in our own kind of edge location in an outdoor area. So this was effectively a parking lot. No electricity, no networking, et cetera. Viasat came along with 3 levels of redundancy. There was the main satellite uplink, there was a secondary satellite uplink, and we had fallback to LTE as well, which gave us that aspect of high availability. What we brought along then from AWS was the compute facility. And this came in the form of a Snowball Edge, which you can see in the bottom right of the photographs there. This is a hardened server range that AWS produces. And when I say hardened, I mean not only from a security perspective, but also from a physical build perspective. It's meant to be deployed into challenging environments. It can withstand 200 Gs of impact, so it can be deployed from an aircraft flying overhead. It's designed from the ground up for these harsh environments. So the demo we built to showcase what Viasat brought and what AWS brought along, we decided we'd base this around image processing and the ML-based image processing services that we have at AWS. So we set up an IP webcam on the truck, which was sweeping the area around the booth. We had a custom-written app deployed on the Snowball Edge, which then consumed the video stream from that IP camera. The stream was then pushed back up into AWS to a machine learning image processing service called Recognition. Recognition then analyzed that stream and passed back labeled images to the user in a simple web browser interface at 1 second intervals, showing what had been identified in that video stream. So we spotted a boat, we spotted a human, we spotted an aircraft briefly, we spotted a person. So I think what we succeeded in doing was we powerfully demonstrated the use of Viasat's comms along with AWS compute to provide the end user with real-time video analysis capability regardless of their location. So very much showcasing the kind of symbiosis of Viasat services with AWS's services. Okay, Phil, back to you.
All right. Thank you. I think what Jeff actually mentioning is actually truly highlights some of the very important points on how do we deliver this cloud capability basically to the warfighter, right? Go back to the previous slide. What you can see is that we actually have connectivities to the hyperscale cloud from AWS, but also in the technical environments, we actually have been able to actually put a Snowball Edge basically, which is in our terminology, we actually call it the tactical cloud. And the reason is because in dynamic situations, you're not always 100% will be able to actually get the satellite connectivity to the point that you actually wanted to. It's actually, we actually have a name we call the DD environment basically. It's like disconnected, disadvantage, intermittence, and link. Those links are actually not always available. So what we actually have been able to do and actually demonstrate for both basically in this environment and also in the CA and space environment is the fact that you can actually pre-stage all your data and your processings in the tactical cloud, in this case, the Snowball Edge environments. And then you can actually go run your ALMI model, basically, to do image recognitions and all the other capability. You can, when the connectivity is back, basically, to the hyperscale cloud, you can actually send a lot of data back there and do the training, basically, in the hyperscale cloud, which likely going to actually require a lot more data, and you actually need to fuse a lot more data that way, as well as the processing capability. But then you can actually generate a better and better models, and then you can actually send that model into the tactical cloud, and then you can actually use it in the field. So this is actually one of the key things that we think is actually very important, both Viasat and AWS, is to be able to actually bring the cloud capability to the edge without always actually have to go back to the hyperscale cloud. And this is a very important thing that we have been demonstrating, both in these environments and also in the sea environments. But it's actually not just land and sea as well, right? We are actually looking at in the air, in airplane, basically, they actually experience the same kind of capability. A lot of time when you actually go look at providing technical communications, airplane is actually important. The reason is because airplane is actually flying in a much high altitude, and because of that, they can actually cover a lot more ground, basically, if they actually have direct connectivity with the ground forces and other peoples in there. So in this particular case, we can actually even actually put a Snowball Edge in the transport plane. So they will become almost kind of like a mobile tactical cloud that you can fly anywhere, basically. You can actually upload geographical locations, maps, you can actually AIML models, basically, and a lot of data can be actually stored on those airplanes. And then you can actually fly them around and actually able to actually provide cloud connectivity and capability anywhere in the world, as long as you can actually get your plane in that way. So this is actually what we call ACE, agile combat employments, is abilities to be able to, once again, through the communications capability of satellite communications, tactical communications, connectivities to the AWS cloud, and also a tactical cloud like Snowball Edge, have that ability to actually give this capability everywhere around the world. And another important things that we can actually do that also is the fact that we can actually data fuse a lot of the air asset so that we can know, we'll be aware of, okay, where they're located, what do they see, ability what we call understand where your asset is basically and what you have is actually very important. And a lot of times, the best place to do those data fusion is in the cloud, because you can be in one location that you actually are aware of this particular 200 miles radius, basically, scenario, and then you actually go to another one, basically, another 300 miles radius scenario. But those actually have really great relationship that a commander might actually want to understand. And the best place to do that would be is that we can actually fuse all those data through our SATCOM capability, do it in the cloud, and we can actually merge them and develop much better understandings of where things are. So it's actually what we can actually develop a common operational pictures. We can actually do like unified management of the air asset, and then you can actually use all those informations, even if you're not using for real times, but later on to use to see, okay, this is actually what happens. You can do that for trainings, and you can actually use it for advanced planning also. So we actually go through, okay, so you can actually get to the cloud from land. You can get to the cloud from the sea. You can actually get to the cloud in the land. Well, recently we have been actually awarded a contract basically from NASA. It's actually called Communication Surface Projects. This is actually really groundbreaking, basically. We can actually connect space asset, basically, space directly, basically, through our SATCOM systems and actually to the AWS cloud. The whole idea would be is that nowadays there's a lot of what we call sensor satellite, Earth observations, infrared, and other sensor satellite. And you have, right now, most of the times you see from that is actually what we call a direct-to-Earth capability. But because the rotations of the LEO satellite don't always actually go to the ground station pretty often. So you actually have a lag time between where you can get the informations to the time that you can actually get the informations. Well, in this particular case, what we actually try to do is to actually demonstrate the fact that we can actually have relay basically through our Viasat 3 constellations. So what will happen is that a LEO satellite can then go through our SATCOM system in real times, and then actually coming down to Earth, and then we can actually put directly to AWS. So right now you can actually get like real time. If your system is actually a providing video system, you can actually get that information directly from the sensor satellite in real time, basically, and then you can actually get the information. You don't need to wait anymore, basically, to do that. And that's going to be able to actually revolutionize a lot of things that we do. So this is something that we're actually really excited about, abilities to be able to do that. So in conclusions, Viasat and AWS have been working together for more than 10 years. This relationship allows us to be able to have rapid capabilities to actually able to deploy a lot of different things. We have been able to do machine learning, data analytics, and space ISP service in a scalable way. Because when we actually go build a satellite and set up a satellite systems, not all of the customer will actually come all at the same time, basically, right? So when you actually have a satellite systems, maybe the first 6 months you get like 25% filled up, the next 6 months you get another 25. And with this capability, basically, we have been able to scale up our data analytics and our management using the cloud. To say that we actually use many different fundamental capability infrastructure as a service with ECS and S2, but we also are actually moving to use some of the more advanced service like SageMaker to actually improve our capability and actually save development times and have have abilities to be able to rapidly deploy the capabilities. On top of that, though, we are actually also working with AWS very closely to actually develop the same kind of capability that we can have all around the world. Doesn't matter whether or not you are actually in the middle of Africa, whether or not you are actually in the oceans, whether or not you are even in the air, and even in space, we have been able to actually get that capability so that you can connect anybody, actually critical infrastructures, emergency operations. You can actually get the power of the cloud delivered to you no matter where you are. And then with the tactical cloud capability is actually even further provide that capability even at the times that you might not have 100% resilient satellite operation capability. It's the fact that you can actually run the system basically in any kind of scenario. When you can actually get back to the satellite systems, you can actually go refresh your capability, what we call like your tactical environment, you can actually refresh the capability. And then afterward, basically, you can actually drive around. You can actually have the smart soldier. You can continue to actually have that capability all the times. And the most important thing is that I think the combinations between AWS and Viasat is actually able to actually accentuate our importance. Is because there's two things actually important right now in the world. It's like, can you actually do your storage and processing in AI, MI, and how can you actually get that information in and out to provide this kind of capability? So by working together, basically, we have been able to actually get that into many different locations in the world and allow us to be able to actually bring everybody, actually, not just the privileged world, basically, into the 21st century, have this capability to allow us to do artificial intelligence, allow us to be able to do machine learnings, and also actually leverage a lot of the investments and a lot of the things happen in space right now. So this will conclude our presentation today.